Hello everyone. Let us solve the definition of converting a decimal number into a binary equivalent number. So basically a binary number is a number when a decimal is divided by 2. The remainder that is obtained, either 0 or 1, is collected in the reverse order and that forms the binary number. So for example, if the number was 4, then taking the modulo division, we would get 2 with the remainder 0 and then 1 with the remainder 0 and then 0 with the remainder 1. So the result would be 1, 0 and 0. So that is the logic which we are going to apply. So let us start with the input. We already have the number here, converted it into a number and checked for its validity, whether it's a number or not. Now another thing that we'll have to do is also make sure that the entered value is a integer number, because if it is having a fractional part, the fractional part has the method of conversion to binary by multiplying the fractional part with 2. So that's a different method. Here we are going to do the division. So at this stage we would even want to check that the input is integer or not. So okay, so if it is an integer, then we would do the binary conversion. Otherwise, um, we would throw an error message. So it's not an integer. So let us start with the first thing. Now, in the beginning, I'm going to take the binary as an empty string, and as and when I come across the value, the remainder value, I'll keep concatenating it with this variable. So while the number which is there in B is greater than 0, we are going to do this logic. So we'll do something, and once we are done, we are going to come out and simply display the binary equivalent. So we print the binary variable and we are done. Okay, so there would be two things we'll have to do. First is we'll have to find the remainder. So let's say remainder is equal to the number remainder division by 2, and then we're going to have B as the floor value, because we'll have to reduce the number. So we'll take the floor value of B divided by 2, and this process will continue. So say if I enter 4, then 4 modulo 2 is 0, so 0 will come here, and then 4 divided by 2 is 2 will be stored here. So the next division would be 2 modulo 2 is 0, and 2 divided by 1 is 1. Right, so this logic will go on. So one more thing, now I need to construct my binary string as well. So I'm going to take, because I need to prepend the remainder, I'm going to take remainder plus binary. Okay, so let us go ahead and try this definition and see whether it is working. So if I enter, say, a 4, I'm getting correct value. Let's say a 5, and this is correct value. Let's say a 7, all ones, working fine. 8 is working fine, and 10 is working fine. So the logic is working fine. So the whole idea is you take the original number and modulo divided by 2 and catch the remainder, and then integer divided by 2. That is why we have used the floor function, And then when you're forming the string, when you're taking the division remainders, you actually go in reverse. And that is the reason I'm prepending the remainders that we are getting at every stage. Try this definition and I'll teach you a new problem definition in the next video.